Good morning all of you. In this class we have discussed about the encoder and decoder. This is one of the application of combinational logic circuit. Okay, this is one of the application of combinational logic circuit. This is the basically introductory class of encoder and decoder. So they are combinational circuit, as we are having with the first point, that is combinational circuit. They are used to convert. This is one of the very important point in this encoder and decoder. They are used to convert the data from one form to another form. They are used to convert the data from one form to the another form, as we will discuss that part later. Next, the encoder have n input and m output, while your decoder have the m input and n output. Okay. So by using this about discussion, we can say that the function of decoder is opposite to the encoder. The function of decoder is opposite to encoder. So we are having with these two block diagram of encoder and decoder itself. So first we'll discuss about the encoder. Encoder as here many input and many output. In our previous video, we discussed in multiplexer as many input and single output. But in this encoder and decoder have many input and many output. So here as many input as n input and m output in this encoder. So here that's why we have written that n input in your encoder as n input and m output. This is what your encoder. As decoder, exactly opposite, as already I told you that decoder have m input and n output. So this is the block diagram. This is the generalized block diagram of decoder, where m input as the number of input lines, and the n output, that is number of output lines, that is n. Okay. So based on this, we take an example of 4:2 encoder. So first of all, we'll discuss how it should be how we can find out the input output line. Okay, suppose we are having with as our relation n is equals to 2 raised to power m. That is our relation, that n is equals to 2 raised to power m. So the number of input are 4. Number of inputs are 4. So it's equals to 2 raised to power 2. Is equals to 2 raised to power 2. So by using this relation, we can say that value of m is equals to 2. So that's why we can say that we are having with 4:2 encoder. 4:2 encoder. Likewise, we are having with, if suppose the number of value here 8, the n is equals to 8. So here the 2 raised to power 3. So for this 8, we are having with 3 output. So that's why it's going to be 8:3 encoder. Okay, so one by one we'll discuss that part. So we have taken example, today we have taken example of 4:2 encoder. So here as 4:2 encoder, as the basically if you see here that according to the block diagram, that block diagram has n into m encoder. So in this n is 4 and m is your 2. So n is 4:2 encoder, that 4 input line. If you see here the 4 input line, that is D0, D1, D2, D3, basically the data line. Yes, it is one of the application of encoder, that is to minimize the data line. That one of the application of this encoder is used to minimize the data line. And here as the 4 inputs and 2 output, that is Y0 and Y1. Next, here if you say that you are talking about the decoder, now decoder is exactly opposite. So here 2 input and 4 output, as inputs in this case are 4 and in this case the output is 2. So here what n and m. So likewise here m should be that 2 and n should be 4. Okay, now here that output of your encoder that encodes, and here that output of this encoder is what input of your decoder. to decode. That word itself says that, sir, that is encoder and decode. Encoder encodes the data and decoder decodes that particular data and give it the output in terms of this original data, that is input line. So here, if you talk about the data, that is, if you consider the input line, that is 0, 0, 0, 1, 1, 0 and 1, 1. Okay, if you talk about the input line 0, 0, 0, 1, 1, 0 and 1, 1, and here that number, if suppose out of this, let us consider this D2, that is 1, 0 is active high. If you consider this 1, 0 is what active high, is what 1, 0 is what your active high. So here, because of this active high, here the output we are having with is 1, 0. The y1 and y0 and y1 is what 1, 0, as we are having the output y0 because this active high out of this. Now that input to that decoder that decodes that data adds 1 and 0. So here, because of this 1, 0, that which one active will get the output as a D2, because here that D2 value again 0, 0, 0, 1, 1, 0 and 1, 1. Let us see how it should be by using functional table. Okay. Now that functional table of for your functional table. Now here, if you talk about the encoder only, if you talk about here functional table of 4:2 encoder. Okay, today we discuss about this, that encoder. Now here that input line as inputs are D here D3, D2, D1 and D0. Okay, that input at MSB to LSB, that MSB to LSB, that D3, D2, D1 and D0, and the output we are having, that is Y1 and Y0, Y1 and Y0 as a output. Now here that input from this, that is 0, 0, 0 and 1. If suppose the D0 is active high, so for this D0 is active high, so the value here we get some 0, 0. So value is we got some, that is 0, 0. Next, if suppose we are talking about the D3, D2 and D1 is going to be active high, that is D1 is going to be active high. So the value here we got some, that is the D2 is active high. So here the value is 0, 1. Okay. Now talking about the again D3, D2 is going to be 1 and here 0 and 0. So Y1 and Y0 is what 1, 0 and here 1, 0, 0 and 0. So here it should be 1 and 1. So here that D3 is selected as a 1. If suppose the D3 is selected 1, so we are getting the output as a 1, 1. As in our previous case, as already I discussed, that D2 is selected as a 1, so 1, 0. So here 1, 0 is going to be in a output. So by using this, if you talk about the equation, of this, so Y1, in this case Y1 as 1 for D2 and this one for your D3. That Y1 is 1 for D2 and this for your D3. Likewise, in this case, your Y0 here 1 for your D1 and this Y0 is for your D3. So by using this, if you write down the equation for this Y1, so Y1 is equals to your D2 plus D3. So it is going to be your D2 plus D3. Likewise for your Y2 is equals to your D1 and D3. So this your D1 and D3. See, you can find out this value by using K-map also, but in this case only that according to the definition of encoder, at a time only single value is going to be active high, and in this case we have no need to go for K-map. You can directly find out this equation by using this. See, it is y1, it is what D2, and y again D3. So by using this you can find out the value of this. Now here, as the value of this data line we are having with D1, D2 and D3. So consider that for this combinational circuit, so we have to just draw the combinational circuit for this combinational circuit diagram. So here we have to just draw the combinational circuit diagram. So input line, that is D1 for the input line. Now here the D2 as input line we are having with that D2. Next here that D3. So here 3 input line we are having with. Now next consider D2 and D3. So for Y2 it should be your D2 and D3. So here we have to just consider from this, that is D2, from this, that is D2 and D3. It is nothing but your Y1. So this is what your Y1. Next Y2, D1 and D3. So here that one of the line from this D1 and one of the point from this D3. So here we have to just find out the value, that one of the line from D3. So here should be your D3. So in this case we are getting the value for Y2 also, Y1 and Y0. Okay, it should be your Y0, and here it should be again Y0. Okay, Y1, Y0, Y0, here also Y0. So in this way we can draw the combination circuit for your 4:2 encoder. In this class we will discuss about this encoder, this functional block diagram also, and functional table of this 4:2 encoder. This is the block diagram, and they'll take an example for 4:2. Here the equation, and next is your combinational circuit diagram for this. Okay, thank you.